Hi, today we're going to graph this rational function. So first we want to make this very easy on ourselves. So we want to look at these quadratics right here and factor them if we can. So let's rewrite this function as y equals x plus 5 times the quantity. Well, this will factor to x minus 1 times x plus 3. And on the denominator, we'll have x plus 3 times x plus 4. And so looking at this totally factored form, we see something weird. We have an x plus 3 on the denominator and an x plus 3 on the numerator. So when this happens, we have what is called a hole, because these two x plus 3's will cancel out. However, we cannot plug x equals negative 3 into our equation, because if we do, then we'll get a 0 in the denominator, and that will be undefined. So we can cancel these out, but we just have to make sure that x equals negative 3 is not in our domain. So now we have x plus 5 times x minus 1 all over x plus 4. That is our new function with a hole at x equals negative 3. So there we've accounted for our hole that we had earlier. So now let's go through the usual process of graphing a rational function, which is first we find the zeros. And we find the zeros by looking at the numerator. What x values will make the numerator equal 0? So we already know that if we plug in x equals negative 5 for this factor and x equals 1 for this factor, we'll get 0. So our zeros are x equals negative 5 and x equals 1. Alright, next step, let's find the asymptote. So vertical asymptote, we look at the denominator and see when is the denominator equal to 0. And the denominator is equal to 0 at x equals negative 4. So vertical asymptote at x equals negative 4. So this function also has a special asymptote called a slant asymptote, which occurs when the degree of the numerator is 1 greater than the degree of the denominator. So in this case, we have a degree of 2 up here and 1 down here. So we have a slant asymptote. To calculate the slant asymptote, we need to divide the numerator by the denominator. And so for ease of dividing, we are going to combine these two terms. So x squared plus 4x minus 5. And then we'll divide it by x plus 4. And so using our polynomial division skills, we'll put an x up here, put an x squared and 4x down here, subtract these two, bring down a negative 5, and then since the degree of negative 5 is less than the degree of x plus 4, we'll put this as our remainder. So this is our quotient. And when we're taking our slant asymptotes, we really want to be looking at what this expression does at very, very large or very, very negative values of x. And so when this happens, this negative 5 over x plus 4 will become very, very tiny and very, very insignificant. So this expression here will approach y equals x. And so our slant asymptote will be at y equals x. So now that we have all this information, let's go ahead and graph it. So let's start out with zeros. Zeros are pretty easy. So we have a 0 x equals negative 5, and x equals 1. We have a vertical asymptote at x equals negative 4, x equals negative 4, and we have a slant asymptote at y equals x. So this is about y equals x. Next, we have a hole. And for the hole, we want to plug in x equals -3 into the function that we have after we take out the factor of x plus 3 from both the numerator and the denominator. So plugging in x equals -3, we get y equals 2 times -4 all over 1. So we get -8. So we have a hole at -3, -8. 1, 2, 3. There we go. And so now we can figure out where our lines are going to be. So we know that nothing is going to cross this line, and we have a 0 here. And we have a slant asymptote here. So our function is probably going to go something like this. Picking up from this asymptote, we have a hole here, so we know that our function is going to somehow be around this area. And we have a 0 here. So we know that our function is going to look a little bit like that.